Hi folks, welcome back to Physics with Captain Rod. Make this video here to get you started on your, the beginning of your Unit 4 homework. First assignment here. Actually, I'm sorry, this is the second one. Not the first one, but okay, anyway. We're just going to look at problems 1, 2, and 3, and all three of these problems are about a quantity called density. So a little review here. Here's how density is defined. It is defined as mass per unit volume, as units of kilograms per cubic meter in the standard SI units. Equation-wise, you'll see it written like this quite a bit. And this is the Greek letter rho, a very common variable to represent density. So these problems are basically about density calculations. The first one says, let's see, something about a block of copper on a flat level floor. So we got, this block of copper. We might start with just a quick picture like we do. Whoops. Something like this, sitting on a floor. The density, right, is given. This is a number given in the problem. And the mass is also given. So I think I would start this out by, okay, density is mass over volume. And in the problem, the density is given, and so is the mass. So what you're going to do here is calculate the volume. And I'll let you go ahead and do that. Part B, the surface area that's in contact with the floor is given. So that would be like, it'd be like this top surface, assuming the top and the bottom. And if we look at a free body of the block, you've got the gravitational force down, mg, and you have what we call a normal force up on the block. And that normal can be expressed in terms of pressure. So hopefully you've seen, you are familiar with this, but pressure is defined as force per unit area. So the normal force from the free body must be equal to mg. And these are values that are given in the problem. So that normal is divided out amongst this surface area. I'm circling the top one, but it's actually on the bottom. So take calculated force, divide by the area there. That's going to give you the average pressure. So that's a long-winded version of number 1. All right, let's chat about number 2. Let me get rid of some of this stuff here. I'll leave that. Oh, let's see. Number 2 says something about a man standing on a horizontal surface. So, you might want to start with a picture, a better picture than me, of some man standing on a horizontal surface. The volume is given for this man, and his average density is given. So I'd start by writing out, density equals mass over volume. And again, given values. The average density was given, and his mass was given. So you can calculate that man's volume. Part B, where it says, what is the average pressure from his weight exerted on the horizontal surface? So the surface area here of his feet is given in the problem. And pressure is force over area. So really it's the normal force here between his feet and the ground, which is equal to the weight, by the way. Use that for the force, divide by the area, you'll get the average pressure. Let's see, number 3. I'll just write this over here to the right. Let's see, calculate the mass of a solid gold bar that has the following dimensions. So there's a bar of gold. We might want to start with a quick picture. Okay. The length is given in the problem, the width is given in the problem, the height, they're all there. The density of gold, also given in the problem, and that's equal to mass over volume. So again, you're given that value. You can calculate this from these values, and then calculate the mass. So that should be plenty to get these problems done. Hope that gets you well underway. Have a great day.